Okay, this is page 2 of the conic review. So number 5. This is a circle because there's a radius. Like if you wanted to, you could divide all of these by 9. But the 3 and the 3 is going right and left, 3 is going up and down. That's a circle. Okay, center is -3, 1. So -3, 1 is right there. And the radius is 3. So the radius is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I like when you don't have to say what the vertices are. It takes forever. This one you just have to say the radius is 3. Done. That's not a great circle, but best I can do right now. 6. Write the equation for parabola in vertex form that has the following information. Well, I like to do a little sketch to see what this looks like. So 2, -8, 2, 3, 4, 5, 6, 7, 8 is about right there. And the directrix is x equals 3. That's 1 to the right of that. Since your parabola can't touch the directrix, the only way this could go is left. It has to go left. Therefore, this is what a left parabola's general form looks like. So look at your formula sheet. You will notice that you'll see this on there. Okay? So the vertex was given, so we can actually get that part of it. So this is y minus -8, which is y plus 8 squared. And then the x minus 2 parts there. And the p, which in our book we had d, so p or d doesn't matter, it's a variable, is the distance between the vertex and the directrix, which is just 1 unit. So that p is 1. So this is 4 times 1, or just 4, and that's your answer. 7. Find the required information in graph. So now we're going to complete the square. This is, I can tell you right now, because of these two terms, is an ellipse. Because the coefficients of x squared and y squared are both different and they're both positive. And it's because you have two square terms, it's an ellipse. So to complete the square, we're going to group our x's, leaving space for a third term. We're going to group our y's, leaving space for a third term, and we're going to add 39 to the other side. So let's take a 7 out of this. So half of -6 is -3. -3 squared is 9. 7 times 9 is 63, and that is what we're adding to the other side. We're not adding 9 to the other side, we're adding 63. For the y family, we're going to take a 3 out. So when you complete the square, half of 2 is 1. 1 squared is 1. If you distribute the 3 in, we're adding a 3 to the other side. For a grand total of, I don't know what this is. I think I've got 42, 45, 105. These are weird numbers, so let me look. We've got 39 plus 63 plus 3. 105. I don't like this number. Where's my perfect squares when I need them? So now what we're going to do to get this equal to 1 is we're going to divide everything by 105. So 7 goes into 105. What's 105 divided by 7? 15. So this is going to be x minus 3 squared. So I'm going to complete the square at the same time as dividing over 15. So it's not a perfect square, but life's not perfect, right? And then this one's y plus 1 squared, and 3 goes into 105. 105 divided by 3 is 35. Oh, no perfect squares. All this equals 1, and this is the standard form, and it's an ellipse with center 3, -1. They're going to make us give it these ugly vertices here. So, a squared is 35. So a is plus or minus square root of 35. Square root of 35 is about 5.9, and that's under the y. So you're going to go about 6, but not quite 6. 5.9. 1, 2, 3, 4, 5.9. So it's like right there. 1, 2, 3, 4, 5.9. That's the way that moves. You guys see that? I moved 5.9 up and 5.9 down. Now, I really don't want to give a decimal. So how could I give those vertices? You'll notice that they're on the same line as the x equals 2. What do these numbers go by? 1, 2, 3, 4, 5, 6. This is a 1's here. This is a 2. All right, so this is a, let's say, the same line as a 3. So we got 3, comma. Then take the center, the -1, and we're going to add and subtract square root of 35 to that. That's your major vertices. I know it's ugly, but when you don't have a perfect square, you just got to do your best. Now, b squared is 15, so b is plus or minus square root of 15. Now, square root of 15 is approximately 3.9, and that's going to go left and right. 1, 2, 3.9. So we have enough to draw over our ellipse. That's our ellipse. Okay. Now those vertices they share the same y side as the center. So that means the -1 is going to stay the same. So you're going to take the 3 and you're going to add and subtract square root of 15 to that. And that's how you write your co-vertices. Now your foci, maybe our foci will turn out better. Your foci is a squared minus b squared. So a squared is 35 and b squared is 15. So that is 20. So that's ugly too. Plus or minus 20, which is like 2 radical 5. But square root of 20 is 4.5-ish. So your foci would be up 2, 3, 4.5. 1, 2, 3, 4.5. That's how you plot them. And how do you say them? They're on the same line as the x of the center. So that part's going to stay the same. It's the y coordinate that's different. So it's -1 plus or minus 2 square root of 5. So those are not beautiful. I apologize. 8. Hopefully this one's better. First of all, this is a parabola because only one term is squared. And that is it's going to open left or right because the term that's squared is y. So this is going to be a left or right, and we're going to just figure that out after we complete the square. So let's keep our y terms on this side and put anything that doesn't contain a y on the other side. So subtract x and subtract 68 to the other side. Now you're not allowed to complete the square if there's a number other than 1, so we're going to factor a 4 out. Half of 8 is 4. 4 squared is 16. And we're adding 64 to the other side. So it looks like this. So on this side, we have 4 times y minus 4 squared. That's half of -8 right there. This side, I'm going to factor a -1 out. Make that x plus 4. So everything's looking good except for this 4 right here. So we're going to divide both sides by 4 to get this y minus 4 squared by itself. And over here, this would be -1/4 x plus 4. That's standard form. So the vertex, there's the x, is -4, and then the opposite of its y is 4. Remember, find the x first, which is right there, then the y. Your 4p is going to be equal to -1/4, so p is equal to -1/16. Another ugly p. They have some hard problems in this section. This is opening left, by the way, because y is squared, so it's right or left. This is negative, so it's opening left. Let's write that big. We know that it's opening left. And we're going to go -1/16 to the left, which is right there. So what is that point? It is -4 and 1/16. And then the same y coordinate, 4. The directrix is 1/16 the other way, but it's a vertical line. So that is x equals -3 and 15/16. So the lattice rectums are pretty small. Actually, this is probably it's probably going to be this skinny because the lattice rectum is probably not that fat. The latus rectum is only 1/4. So it's like the length of 1/4 is like a half and a half right there. So it's not very big. So it's a very skinny parabola. Okay, 9. Find the equation in a circle that is tangent to the equation y equals -2 and has a center of -612. All right, center is -612. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the center. And it's tangent to the line y equals -2, which is down here. That means your circle has this radius. So it looks something like this. So we have to figure out this radius. We have the center. We just need the radius. So remember, this center was at -612. So right now it's currently 12 up. So the radius is at least 12, but it's another 2 because you have to go down to -2. So the radius is 12 plus the 2 that you went down. So the radius is 14. So your equation of this circle is 196.